Welcome to Mr. Sou's Math World. Today we are going to discuss two MC questions of homework 10. The first question I want to discuss is MC question 3. Okay, so for MC questions 3, you can see that it says the first pattern consists of one dot, and for any positive integers and the n plus 1 pattern, that means the new one, is formed by adding 2n plus 2 dots to the old one. Nth pattern, right? The old one. And then you are asked to find the number of dots in the X pattern. So there are many different ways to do, okay? So actually you may not need to use AS because probably not, right? Okay, that means you can throw these two concepts away and then we just count it one by one. So there is a method like just do it one by one. So some of you say, isn't it really stupid to do so? Or it may not be really stupid because when you are drawing, you can get some concept of it. Okay, so you can see that by adding 2n plus 2 dots, it means every time you are having more and more. Okay, so it is actually a kind of exercise which requires you to draw, okay? But for the X one, I have to draw more. Well, with some patience, you can see that there are two triangles here, with one of them repeated, this one. Okay, so if you use this method, it's not really bad. You can also calculate, right? So it is actually 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 and 8. Add all these together. Okay, add all these. After you add them, multiply by 2 because you get two sets of them. But this one is repeated. Okay, so after you add this, that means 36 times 2 minus 1, you get 71. Okay, so this is the slowest method. So a faster method is, so you can see that from every time you get something, right? 1 and then 5 and then 11. Okay, so by the calculation suggested by the question, so the first one is plus 4, another one is plus 6, and you get the third term, right? So when you got the fourth term plus 8, fourth term, fifth term plus 12 plus 10, 6 plus 12, 7 plus 14, and then plus 16 for the eighth one. But how can I make sure it is correct? So usually I will give buffer like this: first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term. Okay, so let me add the T. Alright, and then that means we add all the red values to 1. Okay, then you can get the answer. Okay, that means 4, 5, like this. So this is already the eighth term in this way. So 1, add all of them. Okay. Let me highlight for you. Okay, so you add all of them together, then you can get the answer to be 72. 72 minus 1, 71. Okay. So this is the comparatively faster way to do so. Okay, remember, you may not need to use AS or GS. Just count it carefully. So this is question 2. Our question 2 is very difficult because first you need to understand, so we got a geometric sequence, so these are different, distinct means different, positive integers, and then we need to handle all these one by one. Okay, so the first step is to handle the relationship of them because they are geometric sequence. Okay, so that means you get this one. Common ratio, R, okay, geometric sequence, equals to B over A, C over B, and D over C. So write all of them. Then we can go to the statement one by one. So the first one we are going to handle is log A, log B, log C, and log D. we are asked to check whether it is an arithmetic sequence. That means we need to check the difference of the term. Okay, so we will check all the three pairs. So I write out the detailed step for the first one for you. Okay, so we need to check the three pairs, and then for each pair we check the newer term minus the older term, and then after you check log B minus log A, we need to simplify by using the log property. Outside minus which goes to inside divided, and B over A is equals to R. Okay, our task is to check whether the remaining two we can also get log R or not. So the second one, we also have log C over B, and then also check it clearly from the list. You can get log R again. So you can see it's the same here. Okay, so quickly we also do the third pair. So as shown like this. Okay, so you can see that all these are the same, and then it is a yes with the common difference equals to log R. So the common difference equals to log R, therefore this is a yes. So this is the first statement. Right now, we are going to do step 3, which is going to check for the second statement. So this time the question asks us to check whether it is a kind of geometric sequence. So we need to check whether we have got a common ratio for it. So second term divided by the first term and so on. Okay, so let's see. So step 1, we substitute. And then step 2, we use the change of base formula. So you will see log B perfect square, and then log C log A. Okay, and then the third one. So after some sort of calculations, you see that these two are not really likely to be the same. And then we are not really sure whether we can substitute inside to see whether it's correct, right? Okay, so when we do so, no idea, so that means it might not be true. But if you say it is not true at this moment, it's not okay. So whenever you think you may get it incorrect, that is in this a fabulous method. So what this is, which is actually you can use the checking method for all part 1, 2, 3. Okay, so method is to let some values, especially in MC, right? This is the MC skill. Okay, and remember you have to let it so that this is a kind of geometric sequence. You may use 1, 2, 4, 8. You may use 1, 3, 9, 27. Remember they must be positive and they are different. Okay, and then the second step is to substitute inside, and then we check for the common ratio, whether they have the common ratio. Okay, so after substitution you can get something like this. Okay, but this one is not ended. Okay, because if you divide it, if you use calculator, you will see it is math error, right? So this one is undefined. So if it is undefined, this one, the first one is undefined because you get the sequence is actually 0, 1 over 2, and you get 2 over 3 and so on, right? So for 0, you must only multiply by 0, right? It is actually quite impossible to have a geometric sequence here for statement number 2. All right. So first one is undefined. The second one is 4 over 3. That means it is impossible. So therefore, statement 2 is incorrect. It is incorrect. Okay. So for the third one, I want to use the MC method to work with you. Okay. So I want to substitute. Maybe I substitute and put it as a kind of sequence first to save time. So after substituting 1, 3, 9, 27 inside, I will get log 3, log 9, and log 27. Okay, then calculate the difference, the new one minus the old one by one. Okay, so you get these two, and then both of them are equals to log 3. So let me show how to use calculator, because many of you say it's difficult, I don't know the rule of the log, and then for MC we can skip the step, right? So let me show how it works. Okay, so for the first sentence, log 9 minus log 3, you will see it is negative 4 point something, and after that you take shift log, you can get the 3 here. Also for log 27 minus log 9, you press shift log, you will get this. Okay, that means the most important thing is after you take the subtraction and then you take shift log, you can get the original value. Okay, because for the value you will take log, it is 0 point something, right? So this is log 9 minus log 3. It is the value already, that means log 3 is equals to 0 0.477 something. Then you take shift log, you can get this one. So right now we are going to check the answer with log 3. So you see log 3 equals to 0 0.477 something. Okay, so this is a calculator skill to handle such kind of question. As a result, statement 3 is also correct. So that's why the answer is option B, 1 and 3 only. So I hope you can have a better understanding for this session. So that's the end of Mr. Sou's Math World. See you next time.